So this is a video on equilibrium. Again, we're talking about doing an ice chart. And so with this, I'm going to go through another example with you to kind of show you how to fill out an ice chart and also to do a graph. So this reaction is SO2 plus O2 goes to SO3. And it's taking place in a 1.5 liter container. And again, another thing I want to emphasize is the fact that all of these equilibriums are taking place in the same container. So you don't have a container for the reactant, you don't have a container for the products, they're all in one place. So at the start of the reaction, there's 0.4 moles of SO3. At equilibrium, you have 0.3 moles of SO2. What are the concentrations of SO2, O2, and SO3 at equilibrium? So again, I could always do an ice chart in moles, but it is more important for you to do it in molarity, because generally speaking, you're going to be asked to find the concentrations of things, but you could do it either way, and then at the end you could do the division by the liters to figure out what the molarity is. But I'm going to show you how to do it with molarity because it's a little bit more efficient. So I am given at the start of the reaction SO3. Now please notice the reason I picked this is because I'm starting with product, okay? So I have 0.4 moles of my product. Well, I'm going to divide that by 1.5 liters, and that's going to give me 0.27 molarity. Okay. If I get product, that means I have no reactant, okay? Because these are reversible reactions, I could start with either side. So this one I did want to show you so that you could see it either way. So I cannot subtract from 0, so this side must be plus, this side must be negative. And again, this is going to come from the stoichiometry. What you might see in my notes is I may have had the 2 written or I haven't wrote it in there. I'm always going to have it balanced for you. So this is going to be 2x. There is a 1 in front of the O2, so that's going to be an x. And this is going to be a minus 2x. Again, there's always going to be something given in the problem that's at equilibrium. So in this case, it is 0.3 moles of SO2. So I'm going to take 0.3 moles and divide it by 1.5 liters to get it into molarity. And that comes out to be 0.20 molarity as my concentration at equilibrium of SO2. Okay, so if this is 0.2 and I know it is 2x, meaning it started at 0 and I got to 0.2, x must equal 0.1 molar. Okay, and again, that is why we need something at equilibrium so we could see what is taking place at equilibrium to figure out what the x happens to be. So if that's the case, then x, it's 0 plus x here, so this has to be 0.1 molar. And then I'm going to subtract from here, again, 0.2 molar, because x is 0.1. So that means I'm going to be left with 0.07 molarity for my SO3. So what's my concentration at equilibrium? My concentration at equilibrium is 0.2, 0.1, and 0.07. Again, I could take this and put it into a KEQ and figure out what my KEQ is. But instead, I'm going to do a graph here on the bottom so that you could see the graphing portion as well. This is time and this is concentration in molarity. Okay, so you're always going to have something starting at a concentration. So this one started at 0.27 and these started at 0. So again, this is just a generic representation of what this graph is supposed to look like. So just eyeball exactly where you would be starting with SO3, and then SO2 and O2 would be down here. I'll move that up so you could see it. So SO3 is starting at 0.27 and these are starting at 0. So this goes from 0.27 down to 0.07. So I'm going to take this down and then drill it over here. And again, I want to put the concentrations over here, labeling my line that I've drawn. SO2 goes from 0 to 0.2. So I'm going to take this line and then kind of go up and then over. So that's going to be 0.2 molarity. And again, you could write the formula on top here so we could keep it all straight. And then O2 is starting at 0 and goes to 0.1, So I'm going to take that and then right over there. And again, this is all ballpark. This is not going to be pretty necessarily. And yes, you might have a line that crosses over another line. There's nothing wrong with that. But do realize that once everything has come to a constant, that's going to be your equilibrium point. And again, this is pretty typical of a graphing style question for a ice chart.